the extension question, but actually with the second part taken off, I don't think it is much of an extension. The situation that we've got is a particle attached, we've got a fixed point up here. The particle is hanging in equilibrium above O. Oh, and actually, no, the fixed point is here, and then it's hanging below here, which is a length A. And then it gets given an impulse, given a speed, so it goes round in a circle like that. So that point, forget about that point. So at some point, it then the string becomes slack. So the string becomes slack, and we've got to work out the value of the angle at which that happens. We've got a downward vertical angle. So if I just carry on that up there, so say this is the point at which it occurs, we've got the downwards vertical angle being this here. So there is our theta. This is also A. At this point, this is where it becomes slack. I'm going to call that point B. And the second part of this question is all about the motion once the string becomes slack. It's very similar to the kinds of questions that we did in our normal maths, connected particles, when the string breaks and then the particle moves on its own, just accelerating due to gravity. But of course, what we're doing there, it's just straight up or straight down. This particle, it will have been travelling at an angle there, so it will continue to go off in this angle here. So we've got a two-dimensional motion. It's called projectile motion. That's something that you'll do next year. So we can't do the second part. We've got our energies. So I've got A there. We're starting off by looking energies at part A. I'm going to call that my 0 level. So my total energy is equal to mg multiplied by 0 plus a half mv squared. And here, normally we've got well, quite often we've got a speed of 0. We're given a numerical speed. But here I know that u squared is 4ga. Of course, that u meaning the initial speed, so that's what I'm going to put in there. So we don't have any potential energy, but we've got a half mv squared is 4ga. So my total energies when it's at A is 2mga. At B, which is up here, we have got a height of A plus that bit there. So if you consider this triangle here, that length there is going to be the cosine component. So the height at B is going to be A plus A cos theta. So my total energy is going to be mg A plus A cos theta plus a half mv squared. By conservation of energies, we equate those to 2mga is equal to mg, I'm going to expand that bracket, mga plus mga cos theta plus a half mv squared. The m's cancel. That goes, that goes, that goes, that goes. I'm going to make v the subject. V squared. I will have, let's do it one stage at a time. So I'll have 2ga, that will go on the other side, that will be minus ga cos theta, and finally multiplied by 2. 2ga minus ga is ga, but I'm doubling that, so it's 2ga, and I've got minus 2ga cos theta. And I can factorise out there a 2ga. So 1 minus cos theta. So that is an expression for velocity. Then we need to resolve. Now I've called this point B, but I think I should resolve at a more general point, so B, but I'm going to assume that there's a tension there, and then in the next part I'm going to take that tension to be 0 because the string's going to be slack. So I've got T going that way and I've got my weight acting downwards. I need to resolve towards the centre of the circle. Towards the centre of the circle, that is the direction that my acceleration's going in. So I can see that I've got the whole of the tension force plus I have got, so you've got a right angled triangle there. That's got to be the hypotenuse. I've got alternate angles, so this is also theta. It's next to that, it's the cosine component, so it's going to be mg cos theta. And that is also acting towards the centre of the circle, so you can see both of those two are acting towards that way. And that is equal to mv squared over r. And our radius is equal to a. This is v squared, so I'm just going to very nicely put that in there. So what I've got here is a general expression for t. V squared is 2ga 1 minus cos theta. And I've still got that a on the bottom. Those a's cancel. T plus mg cos theta is equal to, right, so the a's are gone, so I don't have a fraction anymore. I've just got 2mg, and then I've got 2mg cos theta, that's negative. T equals 2mg minus 2mg cos theta minus another one, minus 3mg cos theta. And quite often a question would want you to find a general expression for the tension anyway. Now we can just use the fact that the string becomes slack. So we have got a 0 tension. So as I said, you could just have, done this from this stage, having no tension in there, but just for practice, having it in there, I think, is useful. So string slack t is equal to 0. So this expression here, I know that 0 is equal to 2mg minus 3mg cos theta. We've got to show that cos theta is equal to 2/3. I think you can see that we've got all those bits in there. 3mg cos theta is equal to 2mg. mg, of course, can't be 0, so they cancel. So 3 cos theta is 2, and cos theta equals 2/3. Okay, there we go. Thank you.